Hello everyone, welcome back. So today I want to talk about more rules of differentiation. So if you saw my previous video just on some of the basic rules of differentiation, and take a look at a few more rules. So our goals today, we'll be able to use kind of mainly three main rules for today. One's called the general power rule. Make sure you can use that to differentiate functions. And also be use the product rule and quotient rules when we have more complex functions, you need to take the derivative of those. So let's talk about the general power rule. So the regular power rule, we often said if you have like a polynomial where x was a positive integer like 0, 1, 2, 3, and so forth, then basically that power rule said that you bring the current power down front, the n down front, and then you subtract 1 from that to get your new exponent. Well, this is actually true not just of an integer, but actually if n is any real number, you can do this. You do the same thing. Let's go over here to the right and do a few examples with this. So I want to find the derivative. And look at some examples involving this. Okay, so number one, let's start with the basic one. Well, first off, let's kind of review the regular power rules. So say we have f of x is equal to just x squared. Okay, so review that. So remember the power rule worked. So then the derivative is to bring the current power down and then subtract 1 from that power to get our new exponent. So 2 minus 1 is just x to the 1, or just simply 2x. Okay. Now, what this rule says, this is true for any power as long as your exponent is any real number. So let's say we have g of x is, let's say it was x to the 2.3. Okay, a decimal, that's fine. All right, same way, works the same way. So g prime of x is going to be 2.3 times x to the 2.3 minus 1. And so that's going to be 2.3 times x to the 1.3. Okay, so that's the derivative. All right, so this power rule extends everything like that. Or even we have something bizarre, like what if, so for a third one, let's say, let's call this h of x. Maybe it was x to the pi. That's possible. Unusual, but possible. So the same thing, h prime, bring the pi down front, bring the power down front, and then just be pi minus 1. And since there's no good way to simplify that, we just leave it like that, but that would be the derivative. Okay, now let's see some examples where this is kind of useful now to actually have us able to take the derivative of other kinds of functions. So what if our power is something like this? So let's say number 4, let's say f of x is x to the negative, or 1 over, let's write it this way first, say 1 over x squared. Okay, now if you remember from algebra, that's the same as x to the negative 2. Okay, these two are equivalent, and so if we take the derivative, let's use it this way. Okay, so once again, the same thing, this power comes down front, negative 2 times x, but here I have to be careful because we're still subtracting 1 from this, negative 2 minus 1. So maybe tempting to think the result's going to be x to the negative 1, but it's actually is going to be x to the negative 3. Okay, so if we do this, then negative 2 times x to the negative 3, then if you want to get rid of the negative exponent, often simplifying you do, this is going to be negative 2 over x cubed. Okay. Let's look at another one. This time let's think about roots and radicals. So I'll also mention here, note, that this also applies to roots, since we can think of any root as basically a power, fractional power. Let's this time, let's say our g of x is such as x squared, or the square root of x. Okay. Now, remember that's the same thing as x to the 1/2 power. Okay, because this general statement here, your root, of course, is the n. That's the second root, and your power of the x under the radical is just 1. So this is x to the 1/2. So then we do the derivative, g prime of that. Once again, bring the 1/2 down front. We do x to the 1/2 minus 1. we have to do little fractions here. So 1/2 and 1 with the denominator of 2, of course, is 1/2 minus 2/2 because 1 is 2 over 2. And that's going to be 1/2 times x to the negative 1/2. And let's wrap it up over here. So we can write that as 1/2 times 1 over x to the 1/2 like this. We can actually multiply across. Several ways you can write this. Let's make sure everyone realize some of the important ways to write it. And so we can combine that into 1 over 2 times x to the 1/2. Multiply fractions, multiply straight across. And finally, I can put this back as a square root if I want. And so this becomes 1 over 2 times the square root of x. Okay, let's do one more like that one. Number 6. This time, just go back to f of x. So called f of x is equal to the cube root of x squared. The cube root of x squared. Okay, so in the same way, this is going to be the same thing. So we have here, convert this to a fractional power. Root goes in the bottom, and the power of x underneath goes on top. So this is going to be x to the 2/3. Then similarly, the one we just did, okay, the 2/3 comes down front. Now I have x to the 2/3 minus 1. And this just did before. Let's put that, we'll practice with fractions. 1 is 3 over 3, so this can be 2/3 minus 3/3. And that's going to be just 1/3. We have 2/3 times x to the negative 1/3. And once again, get rid of the negative exponent. So 2/3 times 1 over x to the 1/3. Okay. And then let's multiply across. So 2 times 1 is 2. And then 3 times x to the 1/3 down here. Then finally, let's convert that back to a root. And so this is going to be 2 over 3 times, that's going to be just the cube root of x. Okay, so that's how we use the generalized power rule. Let's get straight for as long as your n is any real number, we can do that same rule. Now, let's take a look at something else. So for number 7, let's take a look at how we do something else. Let's say we have this two expressions. So let's say this is, call this h of x. And let's say we have x minus 1 times x plus 3. Okay. Now, previously, if we've done this before, what we do is just go through and multiply this through. Okay, FOIL it out, distribute whatever, and basically work. And that's a perfectly good way to do it. What we're going to learn now is something called the product rule. So anytime we have a product of functions multiplied together, then we can always use this. So, and also this indicates in math, there's often more than one way to do something. What we're going to do here is use the product rule. So let's explain how that works. So the product rule says if both f and g are differentiable at x, meaning I take the derivative there at x, then if I take the derivative f times g multiplied together, then you have this little formula. And basically the way it works is you take the derivative of 1, since we're adding, it doesn't matter the order, take the derivative of the first one times the second one, the original second one, and take the derivative of the second function times the first. And once again, as long as you remember you're taking the derivative of one function times the other function, well, it doesn't matter the order since we're adding. Let's come over here and use that. You get this bizarre thing happening with this sometimes. Okay, let's try that again. Dot there to get started. Okay, so we use the product rule. Okay, what that means, so this and the formula is my f of x, and this I'm calling my g of x. And so h prime of x, or we write it as d dx. Okay, so I take the derivative of one of them, first one. Okay, if you notice, and this is a little more complex in the sense that you have to think about the derivative of both. So remember, if you take the derivative of just this by itself, then the derivative of x is just 1 minus the derivative of a constant is 0. Okay, then it's times g of x. That's what the formula says, times the other function, not taking the derivative of it. Okay, then plus, then the derivative of the second function. Okay, and in the same way, that's going to be the derivative of x. So do it each part. The derivative of x is 1 plus the derivative of 3 is 0, then times the first function, which is x minus 1. Okay, then we simplify that. And so that's going to be, of course, 1 times x plus 3 plus 1 times x minus 1. Okay, and so we have x plus 3, then plus x minus 1. Let's combine our like terms. And so it's going to be 2x plus 2. Okay, and that's my derivative. Now, something you can try on your own is you can actually just FOIL this out and then take the derivative like you've probably seen before, and then you'll see you'll get the same thing. Okay. In fact, let me do that. Let's go do that really quickly. Or we do h of x is set x minus 1 times x plus 3. Let's go ahead and do that really quickly just to show you. So we FOIL that. That's going to be the same thing as x squared. You can check this on your own. Plus 2x minus 3. And then you take the derivative of that. Okay, so remember, we can break up the derivative as long as we're adding, subtracting, and take the derivative of each part. And so the derivative of x squared is 2x plus the derivative of 2x is just 2 plus the derivative of negative 3. Because the derivative of 3 is 0. And so that's 2x plus 2, which is the same. Okay. Now, so we can use this product rule. That's another way of taking the derivative. Now, maybe wondering why we're doing it that way for this one. Well, we can do this one either way. Let's do our next example where it's something we must use the product rule. Okay, so for number 8, let's try this. So let's say we have g of x is equal to x squared times e to the x. Okay, this way there's really no way to get avoided. So basically I have to use a product rule here. There's no way to simplify it some other way. So what I'm going to do once again is this is going to be my f of x, the first one, and this is going to be my g of x. Okay, and one's going to use the product rule. And so g prime of x is going to be, so once again, the rule says, once again, it doesn't matter the order here, but I take the derivative of the first one, derivative of f of x, which is 2x, times function g of x just by itself, without the derivative, then plus, then the derivative of g of x. Remember, the derivative of e to the x is just e to the x. And then times the first function by itself, which is x squared. Okay. Then I can write this. So this is going to be 2 times x times e to the x plus x squared times e to the x. Okay. And you see, also taking the derivative of that actually got more complicated as we did it. So it actually, so imagine take like the second derivative to get more complicated than that. But that's how the product rule works. And once again, so this gives you, once again, remember what the first derivative gives you is the instantaneous rate of change of this function at whatever x you pick, or here's the slope of the tangent line of the function at that x value you choose. Okay. Let's look at another one. So say number 9. All right, let's say this time let's call this h of x again. Let's call this 3x cubed plus x times e to the x. Okay, so we can also, of course, incorporate the product rule into other functions as well. Okay, so this is just another tool for you to use anytime you see something that's a product where there's no good way of simplifying it or changing it. All right, so we go right here. And once again, so here, I have to use the product rule here. The first one I don't have to, but I'll use the product rule here. Okay, so start. So h prime of x. Okay, so we take the derivative, kind of 3 passes through, so it's going to be 3. Then derivative of x is 3x squared. Okay, plus, now, it's good practice. Let's just put this in parentheses since we're taking the derivative of this whole thing. It's good practice. We can, so here, for example, this was a, in fact, let's even make it a negative. That's why this is important to do a use parentheses here. Okay. Plus, it doesn't matter that much, but this is a negative. You want to make sure you're distributing the whole thing. Distribute the negative as well. All right. So, once again, think of this as my first function. So, another way to think about the product rule is simply you have to take the derivative of one function times the other function and then reverse the process plus the reverse. Okay. So, the derivative of x is 1 times e to the x plus then the derivative of the second function, which is e to the x, is just e to the x. Its derivative is itself times x. Get rid of that mark. Okay. Then simplify everything we can. All right, so 3 times 3 is 9. We have 9x squared. And then we have minus e to the x plus e to the x times x. And since we have a negative, strip the negative through, and now we have 9x squared minus e to the x minus e to the x times x. And that's my derivative of that function. Okay. Now, for number 10, let's talk about our next rule. And this is called the quotient rule. So it's kind of a, so here, the first with the product rule, we decide how do you take the derivative when you have two functions multiplied together. Now, what do you do if you take the derivative? We have a function made of one function divided by another function, and you have this rule, okay, this formula. Now, this one is more important to kind of remember the formula because since we have a minus here, the order of these does matter. Remember up here, we just have the product rule. You just take the derivative of one times the other function and then reverse that. Take then the derivative of the first times the second times the first, so forth. But here, since we have a minus, we have to be careful of the order. So this is one formula you kind of have to remember if you use the quotient rule. So first, let's show how this works. Let's take the derivative. Let's actually do what we've already done. Kind of show basically how it works. So back on number 4, we did f of x equals 1 over x squared. Let's actually do that one again using the quotient rule. Let's kind of show you the quotient rule works and also show that we get the same thing. Once again, as I said in math, many times you can use you often use many different tools to accomplish the same thing. All right, so let's repeat this. So f of x is equal to 1 over x squared. Okay. And so before we changed this to x to the negative second and then use the product rule or use the power rule. Okay. So here, this is going to be my, for the quotient of the product rule, my top function. So my f of x, well, let me just say this. So let's use the quotient rule. Abbreviate that. So my f of x is going to be 1, and my g of x in the formula is going to be x squared. Okay, now let's see how this works. So f prime, okay, so what it says is I have it's going to write a better straight line. I have a big fraction, okay, Let's go and take care of the bottom first. So the bottom says I take my g of x, my function on the bottom, and square that. So it's x squared, and that itself is squared. Okay. Now, and what it says, I do g of x times f prime of x. So g of x is x squared. Okay. But f prime, so the derivative, in fact, that's something you can even write up here if you want. We're getting ready for this. So f prime of x, of course, is just 0 since that's a constant. And g prime of x is going to be 2x. So it might be a good idea to even write that first, just so you can make things a little bit easier. So it's going to be g of x times f prime, and f prime is 0. So this term is going to go away. That's nice. Minus, and then the reverse here. So it's f prime, so f of x times 1, and times g prime, which is 2 of x. Okay, so now simplify this. So of course this term goes away. So we have negative 2x divided by, and remember, we square, remember, we'll do these exponents. If you square a square, it's 2 times 2, x to the 4th. And of course, let's simplify that. And so that's going to be negative 2 over x cubed. So that's my f prime of x. So let's go back and check, make sure we got the same thing. If we didn't, something is wrong. Yeah, the same thing, negative 2 over x cubed. And here we also got negative 2 over x cubed. Good. So that's the idea of the quotient rule. So the quotient rule is a little more involved because we have to, because like I say, it's a little more complicated format. Also, the order is important since we're subtracting in the middle. Okay, let's look at number 11. So this time, let's do g of x. Let's see. Let's do something like this. So x squared plus x over, how about e to the x? Okay. So once again, let's use the quotient rule. And using the quotient rule, so let's say we f of x, or here is going to be our top function, x squared plus x. And then our g of x is our denominator, e to the x. Okay. Now let's go and do our f prime. So f prime of x is going to be, so actually I should have called this h of x or something. Don't want to make it confusing. Okay. Based on my f prime here, this might function on top. And so that's going to be, we take the derivative of this, derivative of x squared is 2x, and the derivative of just x is 1. Then g prime, okay, remember that derivative of e to the x is just e to the x. And then say, so h prime of x, okay, once again, we have this big fraction. Now, the denominator is g of x, or my denominator squared, so e to the x squared. Okay, then we have g of x up top, first term g of x times f prime of x. So g of x is e to the x times f prime, which is 2x plus 1, minus, don't forget we have a minus here, and f of x, which is x squared plus x, then times g prime of x, which is in this case is also just e to the x. Okay, now of course then we want to simplify. So this part what makes this kind of time consuming is you want to simplify and make it, more usable. So first let's look at the denominator. In the same way, I multiply my exponents together, so x times 2 is 2 to the x. So write that as e to the 2x. Then here, okay, let's go ahead and distribute this through. So we have 2x times e to the x, then plus e to the x, and also distribute the negative. Let's do something here kind of all at once. Hopefully this will make sense. So what I'm going to do is I'm going to distribute the e to the x to each one. It's going to be x squared times e to the x, and also have a negative here. That's going to make that negative. Let's make both these terms negative. So e to the x times x x e to the x, and also since I have a negative out front, that's negative. And then finally, look, see, can I combine any of those like terms? Actually, I can. All right. These two here, this one here and here, are like terms. They both have an x times e to the x. So we're almost there. And so if I have 2 x e to the x minus 1 x e to the x, I have just x e to the x plus e to the x minus x squared times e to the x over e to the 2x. And let's see. Yeah, I suppose I can do one more thing. So this is also one thing hopefully learned in calculus, taking any kind of calculus class. Usually you have to be really good at algebra because a lot of times involves a lot of algebra. And that's, in fact, right now, that's all we're doing, just the algebra part of it. Let's do one more thing, and this is just good algebra practice. Notice each one of these have an e to the x and everything, okay? So let's factor out an e to the x. We're only saying it's still simplifying. Still want to simplify further. Okay. Now, if you notice, everything in the numerator is e to the x. Let's factor that out. Taking e to the x out of everything, we have left with the first one is x plus, taking e to the x out of this, we're left with a 1 minus x squared. Okay, taking e to the x out of that one. And then here, remember this is, in fact, it might be helpful to write this as e to the x squared again. It's the same thing. I will make this clear so I'll be able to cancel out this one and one of these. And so I'm left with, finally, my h prime of x is going to be, let's actually arrange this a bit. So it doesn't matter. I'm going to write this in ascending order, minus x squared plus x plus 1 over just e to the x. Okay, so that's my derivative. As you see, it is fairly involved. It takes a fair amount of work. But that's the idea. Okay, so that's the idea of how the quotient rule works. So the quotient rule is definitely more involved than the product rule because you just have to be really, really careful with how you do it. Now, take a look. We'll do one or two more examples, and let me think about the next one I want to do specifically. Okay, what number is that? That was number 11. So number 12. I think I'll just start right here on a new page, number 12. Let's take a look at this one. So it's going to call this h of x. Okay, let's say we have x cubed minus 3x over x plus 1. Okay. Now, we're actually doing this a couple different ways. So first, let's use the quotient rule again. And then I will show you a different way of doing this. So use the quotient rule. Okay. So once again, my f of x, I'm going to call it what I call f of x. Actually, let's do it down here. I have more space. F of x is going to be a function of the numerator, x cubed minus 3x. G of x is going to be the function in the denominator, which is x plus 1. Okay, then take the derivative of each one. F prime of x is the derivative of x cubed is going to be 3x squared. The derivative of negative 3x is just going to be, of course, pull out the negative 3, and then derivative of x is 1, so just 3x squared minus 3. And over here, g prime of x is nice. It's just simply 1. So derivative of x is 1. The derivative of that of constant is 0, so that's just 1. Okay. Now, so h prime of x is going to be, for a big fraction, so it's going to be the denominator squared, so x plus 1 squared. Okay, then we have g of x first, so x minus 1, kind of smeared together, x minus 1 times the derivative, or f prime of x, so 3x squared minus 3, then minus, and then the opposite. So f of x, which is just cubed minus 3x, and times g prime of x, which is 1. Okay, and once again, still we want to simplify it, just good practice, even though it's a pain. Okay, so we need to FOIL this out and distribute. Of course, here this is easy. We have just a 1 to distribute. All right, So when our denominator is the same, we're not going to try and FOIL out our denominator. We'll just leave it as x plus 1 squared. Okay. So if we FOIL this out, x times 3x squared is 3x cubed. Outer ones is going to be negative 3x. Inner term is going to be minus 3x squared. And the last term is going to be plus 3. And then here, of course, this is just a 1, so it doesn't change anything. But we want to distribute the negative, so minus x cubed plus 3x. Just change the signs. And then once again, still simplify, combine your like terms, and also make it be a good idea to write this in descending order. And so if we look at our possible or like terms, here our denominator is the same, x plus 1 squared. Then notice we have 3x cubed and then minus x cubed. Those are like terms. And that's also our highest power. That becomes 2x cubed. And I'm just going to cross these out as we get them. Okay. We have negative 3x and plus 3x. Those actually just cancel out, which is good. Then we have minus 3x squared plus 3 left. And then over x plus 1 squared. So that's our derivatives. Once again, it does what a derivative does, gives us the slope of the tangent line or gives instantaneous rate of change of h of x. Now, as you can see, this is now kind of a more potentially complicated expression. So we could also do a second derivative. And if you do the second derivative, do it exactly the same way. It'd be a pain to do, of course, be a lot more involved, but the steps, the process be exactly the same. Now, one more thing, I'm going to show you how to do this function in a different way. And that's where we introduce the alternate, I'm calling the alternate to the quotient rule. All right, so my f of x or h of x was, make sure I remember what it was exactly, x cubed minus 3x over x plus 1. All right. Well, let's see. Let me think about something just a second. Because actually, if to do this, introduce something else we haven't talked about really. Okay, yeah. I'll go ahead and do this. So this is going to be different. Let's talk about this on the left. This is what's called the alternate to the quotient rule. So this is what I actually like to do in practice because it's actually easier. I think it's easier to work with. And we'll explain the differences as we go. So what I'm saying is, remember, you can write a quotient, f of x divided by g of x. Remember, I can write g of x is down here, 1 over g of x, the same as g of x to the negative 1, okay, as a negative exponent instead of as a fraction. So I can actually write this as f of x over g of x. I can write this as f of x times g of x to the negative 1, okay? Well, since I can do that, then I can actually just use the product rule. And the advantage of this, the product rule is much easier to remember. So if you remember the product rule, you just take the derivative of one function times the other function, then plus, then switch it up. Okay, it's a lot easier to remember how to do. So in practice, I like to do that. But as we'll see, you can have a nicer form with the quotient rule, but the trade-off is you have to remember the quotient rule because the order, of course, is important up here since we have a negative. I'll show you how this works. And I'm actually introducing something I haven't talked about in the video yet called the chain rule, but that will be something we'll explain in a future video. All right, so what we're going to do, we're going to write this as h of x is equal to x cubed minus 3x times x minus, or x plus 1, or rather x plus 1 to the negative 1, okay? So this is the same as this. I'm just writing x plus 1 with a negative exponent, and of course, these are equivalent, all right? So once again, I'm going to use the product rule. Now, I'll kind of set up the same way. So if I call the first function, call f of x the same thing, call f of x x cubed minus 3x, and g of x is x plus 1 to the minus 1. Then, of course, my derivative here is the same. F prime of x is the same. So 3x squared. 3x squared minus 3. And over here, now I'm kind of introducing something here that's something called the chain rule, which we'll learn in the future. This, unfortunately, is pretty easy to do. But think of this just as it's set. Right now, ignore the plus 1, since it doesn't affect the derivative. Just think this just being x to the negative 1. Okay? Then g prime of x, remember the way to do that is bring the negative 1 down front. You have x plus 1. And then negative 1 minus 1. And so that's going to be, where negative 1 is just negative, x plus 1 to the negative second. Okay? And then there's something called the chain rule, which I haven't talked about yet, but you'll learn soon. Basically, you take the derivative of what's on the inside. Unfortunately, that's just going to be just 1. Okay, so this is a good one to introduce that way. Now, so we use the product rule. Then h prime of x. Okay, and once again, it doesn't matter which one I start with, but I'll just do it the same way here, but it doesn't matter. That's the advantage of the product rule. Okay, so f prime first. So f prime is going to be 3x squared minus 3 times g of x, which is x plus 1, negative 1, then plus the other way around. So the derivative of g of x is going to be minus x plus 1, negative second, times f of x, which is x cubed, minus 3 of x. Okay? Now, let's also get rid of our negative exponents and simplify this a bit. Okay? This is going to be 3x squared minus 3 over, let's put this back as a fraction, over, I can write this as x plus 1. And over here, we have a minus, so minus, our numerator is going to be x cubed minus 3x. We're going to have trouble writing small 3's. Over, and get rid of the negative exponent, that's going to be over x plus 1 squared. Okay? Now, it turns out that this is the same thing. Okay? Turns out that this is the same thing as what we got in our previous result. Now, it might look like it at first, but what you could do if you wanted to do is you could actually go through and actually put this, if you actually put this with a common denominator, you'd find out that it is. In fact, let's take a look. So if I want to get a common denominator, so multiply the top and bottom of this one by x plus 1. Okay. And if you notice, that's exactly what you see here. So basically, if I did that, I'd just be repeating this step right here. Okay. I have 3x squared minus 3 times x plus 1, x minus 1 rather, or x. Oh, crap. I believe I made a mistake. Hang on. Sorry, I put an x. Let's go back here. Sorry about this. I put an x plus 1 here. So I put x minus 1 instead of plus 1. That's going to change things. That's going to be, okay. I apologize for that. I wasn't paying attention enough. Yeah, that's going to make this a plus. That's also make this a plus. That's still going to be a minus. No, well, that's going to be a minus now. So sorry about that. We'll fix that everything. Okay. Fortunately, these are still right. 2x cubed. Let me just erase these. Okay. But it is going to be plus 3x squared. Okay. Then I'm going to have plus 6x. So that's where I made a mistake. Plus 6x. And then minus 3. Okay. Sorry about that. But what happens is basically if you wrote this one over a common denominator, making a common denominator, making one fraction, exactly the same thing we got before. So that's kind of the advantage as far as algebra, the advantage of the quotient rule is that it actually gives you everything over a common denominator. Okay. But this is still a valid expression. Now, one thing you may have to be careful for anytime you're working on homework, or especially for any kind of systems like MyLab, WebAssign, which may have to they may have to be very picky about how you input things. So you may have to put it as one fraction. So keep that in mind. That's possible. That's where we may need to use the quotient rule. But in general, if you actually have to do something like this in practice, this, unless for some reason you need it as one fraction, this is just as good. And to me, I like that better because Don't worry about memorizing the quotient rule if I do it this way, but either way is perfectly valid. Okay, let's back up and review quickly what we did today. So we learned how to use the general power rule. So once again, if your exponent is any real number, could be an integer, could be a fraction, could be a decimal, could be an irrational number like pi, you use the same way. And so also, this is a good way for taking the derivative, how we can take the derivative of radicals as well and roots. Then we look at the product rule and quotient rule for fractions where you have taking the derivative of two fractions or two functions multiplied together or divided. And also looked at the alternate the quotient rule, which is another way of taking the derivative of two fractions divided by each other, two functions divided by each other. And basically, the advantage of this, the alternate, is it's easier to remember how to do it. Works just like the product rule. Disadvantage is it doesn't give you everything over a common denominator. Thank you. Have a good day.